Hi, in this series, we'll be doing the H2 Mathematics 2018 Paper 1. We have finished question 1 to 3 in our previous video, and for this video, we'll now start with question 4. So, let's begin. Part 1, it says that we're supposed to find the roots of the modulus of 2x squared plus 3x minus 2, which equals to 2x. So, the way to do this is you just expand out this modulus sign. So it's either 2x squared plus 3x minus 2 equals to 2x, 2 minus x, or 2x squared plus 3x minus 2 equals to x minus 2, which is the negative of 2 minus x. So then 2x squared plus 4x minus 4 equals to 0. And then x squared plus 2x minus 2 equals to 0. So x equals to minus 2 plus minus square root 12 over 2. Then this part can be simplified into minus 1 plus minus square root 3. As for the other portion, so this part you get, then 2x squared plus 2x must equal 0 now. And when you simplify it, you should get that x must equal to 0 or x equals to minus 1. So there are 4 roots to this equation, which is minus 1 minus square root 3, x equals to minus 1, x equals to 0, and x equals to minus 1 plus square root 3. And then now we are to on one graph, we are supposed to sketch the curve of these two graphs on the same graph. So we just sketch the graph. So you just draw this modulus graph, which is just this 2x squared plus 3x minus 2. Then when you modulus it, everything negative you flip up, so you got this. Then you got the line y equals to 2 minus x, so you draw that. Then afterwards, you just label the points of intersection, which is here, 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 and here. So this is 0. Then you just sketch the parts where they intersect. So it's like minus 2 half. And you should also sketch this, which is 2. Yeah. So then you label the graphs, and that's all you need to do for sketching the graph. Hence, we're supposed to solve down the inequality where this modulus is less than 2 minus x. So if you look at the graph, it should already tell you how to see which one is less than 2 minus x. Well, you see, you want the line to be greater than the graph. So this part cannot be. So the line greater than the graph is this whole portion. So it's from minus 1 minus square root 3 to minus 1. So x can lie between minus 1 minus square root 3 to minus 1. Then this part is above, then from here, now this 0 is all the way to minus 1 plus square root 3. And this part is not counted, so it's from 0 to minus 1 plus square root 3. Hence, for this inequality, x is just within these ranges. And you can deduce that from the graph itself. Now moving on, question 5, they give you two functions, and it's also given that f composed with f equals to g. So given that f composed with f equals to g, what we naturally do is we just sub f x into this f to get the f composed f. So f composed f is this portion. So it's just the x now is replaced with x plus a over x plus b. Then you plus a. Then the other one is x plus a over x plus b plus b. Then this part must equal to g, and g is x. So this part equals to x. Then we try to simplify this. So you multiply the here, then it's over x plus b. Then over here you also multiply up. So it's over x plus b. So these two x plus b can cancel out. So you just need the numerator. So it's x plus a times x plus b over x plus a plus b times x plus b. Then equals to x. Then you just cross multiply to make it even nicer. So then you try to expand out and simplify, and you want to simplify, you can bring everything to one side and you should get this quadratic equation where 1 plus b whole thing times x squared plus b squared minus 1 whole thing times x minus a plus ab equals to 0. Then by the comparison, these three terms must equal to 0. So you see that b equals to minus 1, b equals to plus minus 1, and b equals to minus 1. So the common root will be b equals, the common solution is just b equals to minus 1. So that gives us the value of b already, and now we're supposed to find the f inverse. So the step is to always just let y equals to fx, and then y will now equals to x plus a over x minus 1. So this will equals to x minus 1 plus a plus 1 over x minus 1. And I like to do this so that I can make it into a proper fraction. So this is 1, and then this a plus 1 over x minus 1. And by proper fraction, now this part doesn't have any x, which is easy to simplify because you just bring this 1 over. So y minus 1. Then you can flip this 2 times up, divide here. So it's x minus 1 now equals to a plus 1 over y minus 1. And this x, now you bring this 1 over, so it's plus 1 here. Then you remove this. Then you know that the f inverse y must equals to the x, which then equals to 1 plus a plus 1 over y minus 1. So the f inverse x will now, you just need to substitute this y here, you change it to an x parameter. So that gives us that f inverse x equals to x plus a over x minus 1. But it's important to note that the domain cannot be 1 and a cannot be minus 1, and then x still ranges through R. So x cannot equals to 1. Now for question 6, they give you 3 vectors a, b, and c, such that a does not equal to 0, b, a times a, and a cross 3b equals to 2a cross c. So it's like the cross product. And we're supposed to show that 3b minus 2c equals to lambda a. So to do so, we just take a cross 3b equals to 2 cross c. Then you bring this whole thing over. So it's a cross 3b minus a cross 2c equals to the 0 vector. Then because the cross product is distributive, you can take out the a. So it's a cross 3b minus 2c equals to 0. And this means that the angle between them must be 0. So this what does it mean when the angle between two vectors is 0? It means that 3b minus 2c is parallel to a. So this means, and when you mean parallel, it means that it can be written as a scalar multiple of a. So 3a minus 2c equals to lambda a, where lambda is some real constant. So this we've shown the first part. And now we're given that a and c are unit vectors. The modulus of b is 4 and the angle between them is 60. And we're supposed to find the exact value of this lambda. And we know we have to use some suitable scalar product. Okay, so you look at this. Okay, we look at this. We got 3b minus 2c first. Okay, how are we going to use a scalar product to make it a nice thing? So if we take 3b minus 2c and we dot a, that doesn't give us anything because we don't know what's a dot b and we don't know what's a dot c. And we take this 3b minus 2c, you dot b, then we don't know what's b dot, we don't know. We can also use 3b minus 2c dot b, but then we get some number, okay. But then what else are we going to do with it? Because 3b minus 2c is lambda a, then you dot b, you don't know what's a dot b. So we need a way to remove all these a dot b and anything that we don't know. So what can we do is we just take this number and then we dot it with itself because we know it's the modulus of itself. So when you do this, you can expand out and you should get 124 because you just rainbow it. So it's 9b squared minus 12b dot c and then 4c modulus squared. Then you know what is the modulus of this and this, and you know the angle between b and c, so you get 124. And then, but then you can also consider this as a lambda a and this as a lambda a. So when you dot it, you actually don't even need to care about the angle because when you dot it, now it's lambda squared a modulus squared. And a modulus squared is 1, so this is just equal to lambda squared. So because these two are equal, so this means that lambda squared equals to 124. So, and with that, you can just get lambda equals to plus minus square root 124, which is just plus minus 2 square root 31. So, I hope you can see the method of solving it and learn from it. Instead of, so you just trial and error first and you recognize that B and C don't lead you anywhere. This gives us the natural conclusion that we have to have a term that has both B and C, and the natural term is just dotting with itself. So it is common to dot yourself to remove unknowns that you don't know. Yeah, that's all for this video. I hope you have enjoyed it. Please like, share and subscribe, and I'll catch you in the next video. Bye.